Here we will see ASP.NET Core architecture patterns. Architectural pattern defines how application components are organized and communicate with each other. In ASP.NET Core, architecture pattern helps to build scalable applications, maintainable code, testable systems, and enterprise-level softwares. These patterns allow developers to create applications that are easier to comprehend, test, and extend. Some of the architecture patterns that are utilized in ASP.NET Core are Model View Controller, browser pages, RESTful API design, clean architecture, CQRS, that is command and query responsibility segregation, event-driven architecture, microservice architecture, domain-driven designs, dependency injection, repository pattern, mediator pattern, and layered architecture. The MVC pattern is a key architectural pattern in ASP.NET Core. It divides an application into three major components. Model, which represents the application's data and business logic. View, which defines the UI elements displayed to the user, which are often HTML, CSS, and JavaScript. And controller, that handles incoming HTTP requests, collaborates with the model to process the data, and chooses which view to present. ASP.NET Core MVC is particularly effective for web applications that require server-side rendering, in which the application logic decides how data is displayed to the user. Then Razor Pages. Razor Page is a page-oriented alternative to the classic MVC pattern. It makes it easier to design page-focused scenarios by merging page logic and user interface in a single file. Razor Pages isolates the controller and allows the developers to focus on specific page handlers, that is onGet, onPost, and so on, which makes it ideal for smaller applications or the circumstances that do not require the complexity of full MVC. Razor Pages are commonly used for simple apps or crude activities in which each page handles its own UI and logic. Then RESTful API design. REST, that is representational state transfer, is an important architectural style for developing online APIs in ASP.NET Core. This design pattern stresses statelessness, with each API request operating independently, and resources represented by conventional HTTP methods such as GET, POST, PUT, and DELETE. This approach is used in ASP.NET Core web API projects to provide endpoints for interacting with client applications. It is a key principle that includes stateless resources-based URLs and a unified interface based on HTTP methods. Clean architecture. The clean architecture, also known as onion architecture or hexagonal architecture, is a layered architectural design that separates issues by dividing the application into various layers. The basic premise is to decouple the business logic from the infrastructure and user interface layers, which makes it easier to respond to changes and reduce the impact of external dependencies. The core layer contains business entities and domain logic. Different layers of clean architectures are application layer, which provides service interfaces and use cases. Then infrastructure layer, which includes external systems, databases, file systems, and third-party libraries. And UI layer, which contains presentation logic, controllers, and views. Then CQRS, that is command and query responsibility segregation. CQRS is an architectural paradigm that separates read, that is query, and write, that is command operations. In ASP.NET Core, this is accomplished by providing separate service or handlers for queries and commands, which make it easy to optimize and scale each process individually. Commands are used to change the state of the system, for example, create, update, delete operations, and queries are used to retrieve data without changing the state of the system. It is especially helpful in complicated domains or high-performance systems where separating read and write process improves scale and performance. Then event-driven architecture. Event-driven architecture allows components to communicate by emitting and responding to events. This approach is excellent for creating loosely linked distributed systems in which different components of the application can respond to specific events. This can be done in ASP.NET Core using domain events or integration events. Libraries like Mediator and message brokers like RabbitMQ or Azure Service Bus can be used to improve communication between components components and services. Use cases include real-time systems, microservices, and distributed applications. Then microservice architecture. Microservice pattern divide a large monolithic program into smaller autonomous services that are loosely connected. Each service manages a specific business capability and connects with other services via HTTP or message queues. Microservices can be created as standalone ASP.NET Core applications, each with its own database and deployment process. Because services are segregated from one another, scaling, deployment, and maintenance are all simplified. Its key principle includes decentralized data management, individual service deployment, and communication via APIs or message queues. Then domain-driven design. It is a pattern that prioritizes the core domain and its logic. Purpose of this is to make sure that the application's code closely resembles real-world business process it serves. In ASP.NET Core, domain-driven design may be carried out by modeling business relations and entities in the application's core or domain layer. Domain-driven design advocates the use of value objects, entities, aggregates, and the repositories to guarantee that the domain layer is well structured and meets the business requirements. Then dependency injection. ASP.NET Core has support for dependency injections, which is a design paradigm that helps decouple application components by injecting dependencies at runtime rather than hard coding them. Dependency injection is an important component of the ASP.NET Core architecture because it allows for loose coupling between layers and services, which supports a variety of architectural patterns. Developers can register services in the startup.cs file and inject them as needed, which improves the application testability and flexibility. Repository pattern. The repository design abstracts data access functionality, which makes the application easier to maintain and test. In ASP.NET Core, repository serves as a link between the business logic and the data access layer. And this pattern abstracts the mechanics of data storage and retrieval, which allows developers to concentrate on business logic. Then mediator pattern. The mediator design is frequently used to make communication easier between various components or services that are unfamiliar with one another. This approach is often implemented in ASP.NET Core using libraries such as mediator. This can assist in eliminating tight coupling in large systems, which is especially important in circumstances like CQRS and event-driven architectures. Layered architecture. Layered architecture divides an application into levels, with each layer carrying unique duty. Typical layered architecture in ASP.NET Core contains following layers: presentation layer, which is responsible for UI logic; application layer defines use cases and application logics; domain layer, which contains essential business logic and domain entities; and data access layer, which manages database interaction and persistence. This structure encourages the separation of concerns, which allow distinct levels to develop independently.